Thank you very much. My name is Héctor García, and I work for Kepware as the channel manager. I will try to explain you some real-world use cases of OPC UA. This is what I want to share today with you. I will make a short introduction to who we are, what we do, and after that I will go to the use cases. Okay. So about Kepware Technologies, we are an American company. We are based in the US. We were established in 1995. And we have been developers of industrial communications since then. We have been focused on that, and we have many different customers from many different vertical markets, such as manufacturing, oil and gas, building automation, power, and IT. We have a product called Kepware EX. It's our flagship product that is receiving continuously many accolades. We are very proud of that. In the industrial world, which means that we are honored with a lot of recognition in quality, reliability, stability, but also we have added some IoT capabilities, and now we are receiving some IoT accolades. So we are really proud of that. As I told you, we are based in the US, but we cover over 100 countries with a network of distributors. In the Nordics, we are represented by Novotech. Okay, what we do, Kepware EX, this is our communications platform. This is our flagship product. Basically, we can see that nowadays we have many different data sources, as we may see here. In the past, we may had PLCs, but now we may want to receive data from different sources. And in the past, we may have maybe only an HMI or a SCADA system, but nowadays there are many different clients. Those clients like MES systems, ERPs, as we have said, as we saw today, and with different requirements. These applications are very hungry for data, and they are asking many data to our data sources, and keeping in mind that these devices must be focused on their process tasks. They are not experts in communications. So this is where our communications platform may help, because our proposal is to use this communications platform to add to act as a concentrator, to add some security, add some reliability and availability for all the clients, and for each of the clients serving the data in the way they are expecting. Most of them will be OPC UA, but not only OPC UA. Okay. So this is another way to see how Kepware EX can act. We can see the southbound part, the green part. It's the part of drivers, the implementation of the protocols that we have to communicate with the devices of the data sources that we may find in the plant floor or in a building or in an oil and gas plant or whatever. And we have more than 150 drivers. It means that we may communicate with almost anything that you may find in your plant floor. Then we have our core server, which can be accessed using our user interface or external user interfaces, and we serve the information to the different clients. OPC DA clients, that's OPC Classic, also OPC UA, of course, and other different protocols like MQTT and REST that are very common in cloud, in IoT-ready platforms, and also in some other native client protocols. Okay, so we serve the data not only in OPC UA, but also OPC DA and other protocols at the same time. We may have not only one client at a time, but in parallel we may have many different clients. Okay, I like this slide because it explains very graphically what can be done with one single instance of Kepware X. You decide what drivers you will need depending on the devices you have, the protocols you want to communicate with, and you have the PLCs. And once the communication is established between Kepware X and the PLC, or PLCs in plural, you may want to use a SCADA system connected using OPC DA, the classic OPC DA. This was the typical application for many of our customers. They had an HMI or a SCADA system and they wanted to access their PLCs. Nowadays, these SCADA systems are OPC UA enabled, so we, of course, can communicate with them using OPC UA, both ways. You decide. Of course, our recommendation will be to use OPC UA. We, apart from PLC drivers, I told you we have more than 150 different drivers, so we have specialty drivers for flow computers, very common in oil and gas market. We also have protocols for building management systems. We have other protocols for some IT elements like SNMP, and we can convert all this information into OPC UA. We may also find some devices that don't implement standard protocols like barcode readers or weight scales, but they implement very simple protocols of sending and receiving frames, and you can implement those protocols with a special driver that we call UCON driver. It stands for User Configurable Driver. And as I told you, more than 150 different drivers, all of them using one single instance of Kepware X serving data to the SCADA systems in my plant. Okay? And very important is that sometimes some customers already have legacy OPC servers, and we can also connect and act as a kind of concentrator of the communications so that the clients may only need to communicate with one single OPC server instead of creating many different connections. Okay. High availability. We provide high availability, creating two different instances, communicating with the devices, and then putting the data available for the clients in the two different instances of Kepware X. And then the client must decide which one is the correct or the active path, or which one is the standby path. We can send information to databases, historize, whatever, and this is for one single plant I may have. Of course, nowadays, we want to send information outside our plant. Maybe we have a corporate database and we want to send information using the OPC HDA protocol, or we want to send to a corporate MES system using, for example, OPC UA. You know that today, this afternoon, Process has already spoken about security. OPC UA adds a lot of security. So it's really great for communicating outside my boundaries in my factory. Great. We may have also a corporate SCADA system, and we can send information using, of course, OPC UA. Great. And we may not have only one plant. We may have many different plants, many different sites, all of them sending the information to the corporate SCADA. That corporate SCADA can be installed in the cloud, which, by the way, is quite common nowadays. Okay, apart from that, we can communicate with other cloud-based systems, IoT platforms, such as Splunk, which is an advanced analytics platform. Splunk is one of the OPC UA partners. We have a special link for that, industrial data forwarder for Splunk, and we can also send information to the cloud using the RESTful services, MQTT protocol, or OPC UA, for example, to different platforms like ThingWorx by PTC, or any other platform that may reside in Microsoft Azure, Amazon Web Services, Google Cloud, or whatever, because all of them will implement these different protocols. Okay, so in one single slide, you can see that with one single instance of Kepware X, you can do all these things. Very simple. with the user interface. Just configure. You don't have to program anything. Okay, about the communication using OPC UA, as I told you, we have southbound more than 150 different drivers to communicate with any device, and by default, Kepware X is OPC UA server. You don't have to do anything to serve data using OPC UA. And sometimes you want to send information through firewalls through a wide area network to a different location, and you need to transform to OPC UA, and on the other side you will need an OPC UA client. And as I told you, one of our drivers is OPC UA client. It means that we can convert from any protocol here into OPC UA, and then here convert from OPC UA to, for example, OPC DA, which, by the way, is something that's very common nowadays. Okay. Now, some of the use cases. I have 3 different use cases. The first of this is an oil and gas company established in Spain. They had a plant with OPC DA redundant pairs of servers, OPC DA servers, or in pairs, and they had an OCPI historian using OPC DA client. And they wanted to communicate, this was in a remote location, this was in one of their petroleum refineries, and they needed to communicate to this central location. Of course, OPC DA is not suitable for communications using a wide area network, okay? So the solution was to install Kepware X next to the OPC DA servers, and then convert to OPC UA the data coming from these DA servers in pairs, and then transform into OPC UA, and on the other side use the OPC UA client driver and convert again to OPC DA server, so that this historian was able to understand what was coming from here. Of course, this is a simplification of the real diagram, because everything here was doubled because of redundancy. Okay. It was very easy. One of the challenges here was the latency, because the distance was quite high, the bandwidth was quite low, and the amount of data was quite high. So the solution was not to create only one link, or an OPC link or an OPC tunnel, but as Kepware X is designed to be multi-threading, you can create as many channels, as many links, or as many OPC UA tunnels as you want. So you can create parallel threads to communicate each of the groups of tags that you may want to communicate from here to this device. And the key thing here is that they not only had one single refinery, they had 16 different refineries. So all these refineries were connected to this central location. In each of the 16 refineries, they needed to install one Kepware X to convert from OPC DA to OPC UA, but in the central location, they needed only one single license to communicate with all the 16 different data sources coming from OPC UA. Okay. One of the links had a communication of more than 64,000 tags per second. They had very critical information, so the amount of data was quite high. Okay. Second use case, this is a pharmaceutical company. They used to have the historian, also OCPI, by the way, in the OT network, but due to some IT requirements, they needed to move the historian into the IT network. Of course, there is a separation between a firewall between the OT and the IT network. One of the things of the pharmaceutical company is that, of course, they will have PLCs to control how they make the medicines, the pills, but they also have to control the environment, the temperature, the humidity, and many other things, because all these environmental features can affect the medicine itself. So everything has to be historized. So you may see here that you have some PLCs from different brands. By the way, some of the machines had their old legacy OPC DA servers. So in the end, what they did was just install a Kepware EX with the OPC DA client to connect to these OPC DA servers for those special machines. The backnet driver, which is a very common protocol for building management system to control air conditioning, to control temperature and these kind of things. And also the Siemens driver to be able to communicate with all the PLCs they had in the plant. Convert into OPC UA, and then on the other side of the firewall, they could use the OPC UA client to convert into the to OPC DA and send information into the OCPI historian. Okay, this piece was only needed because this software was at that time was not OPC UA enabled. Okay, if OCPI was OPC UA client, you don't need this part at all. Okay, of course, due to pharma regulations, you cannot afford losing data. So the way not to lose data is to add high availability, redundancy. So you have to install another instance of everything and then just cross-connect everything so that if one of the instances falls down, then the other one becomes active and so on. So that's the pharma use case. I wanted to bring this one because sometimes when people want to convert from one protocol to UA, sometimes they think that, okay, we have to send information to the other part of the world through a wide area network. Sometimes it's just to be able to communicate two different networks that reside locally in the same plant floor, but they are separated by firewalls. And OPC UA has many great features, such as security. Of course, that's great, but it has another one. It's firewall friendly. It uses one single port. So it's very easy to configure this firewall, open just one port to be able to communicate those networks using OPC UA protocol. Great, and everything was redundant. And the last one I wanted to share with you is a use case of mining company from here, from Finland. This is, they have 14 different locations. I have showed only 3 of them here, is just to show you that we used Kepware EX to communicate directly with the Siemens devices, the Siemens PLCs, using Kepware's driver to communicate with the Siemens devices, but in other plants, they already had their systems up and running with their own SCADA systems. We didn't tell them, okay, you have to remove everything you have. We just added some functionality. Okay, you already have everything? Okay, we are not going to interfere with your existing plant, with your existing installation. We are going just to get data from the existing OPC DA servers that communicate. In one plant was with Siemens PLCs, and in another one was with ABB devices. Everything redundant, of course, and what our customers made was they created what they called industrial gateway. They put a virtual machine in the cloud, installed a Kepware EX with the OPC UA client to be able to communicate with the 14 different locations using OPC UA. Here it was OPC UA. Here there is a wide area network going through firewalls and so on. And just out of the box, Kepware EX is OPC DA server, so it was possible to send information to one historian, one instance of GE historian they had for each of the 14 locations. And then they had a corporate historian, but it has nothing to do with OPC. In this case, they were copying everything in this corporate historian. But just to mention, ThingWorx. ThingWorx is an IoT platform. The customer wanted to have some analytics from the data they had in their different locations. So in the end, they decided to use ThingWorks to collect the data in real time, from Kepware X in real time, also to historize data, apply some analytics, whatever analytics they needed, using some RESTful calls to the historian database, and then be able to show some dashboards for real-time data coming this path, okay? Or some dashboards of historical data coming this path. So this is one of the customers we have here in Finland. Okay. Great. Apart from our Kepware X product, we also offer some services. Just to mention, we offer some training of our products and also about OPC technology. We also are present in social media, quite active, so you can follow us in Twitter, LinkedIn, whatever. And as I told you, we have partnered here in the Nordics, because not only in Finland, called Novotech. They are experts also in Kepware products, and they can provide you some sales and pre-sales support, also some training and technical support, of course. So if you need to get more information from our site, you can directly contact me. You can contact Novotech. They are here outside, and we will be more than happy to help you. Just to mention, Kepware X can be downloaded for free, can be run for free in demo mode, 100% functional. It's limited to 2 hours of runtime. You just have to, after 2 hours, you just have to restart Kepware X, and you have, again, 2 hours, and you can do it as many times as you want, just to test that Kepware X is the product for you. We are so sure that if you test it, you will like it, that we leave it to you. Test it as much as you want. And of course, when testing, you may have some questions. Send a question to Novotech here or to Kepware. You are welcome to ask us. So, thank you very much. Is there any question?
Thank you, Héctor. Questions? Okay, I would like to ask about your servers. When you are converting from DA or BACnet or from other protocols, are you able to use the information models of OPC UA at the moment, or is it still kind of just...
Okay, in fact, what we do, we don't encapsulate the protocol. What we do is we communicate with the devices. We get the data that you have configured to get from the devices, and then we create an image of the data in our server. And then we are able to send those data in a standard OPC UA protocol. So we don't encapsulate the protocol. We just get the data we want and put it in OPC DA or UA, depending on the client.
Yeah, I think that's the current issue. It's also with the other DA to OPC UA converters that they're not able to really add more information, but especially regarding, for example, BACnet. We have an OPC UA BACnet information model as well, so it would be interesting if you could apply that BACnet model in your server. Yeah, I know it's an advanced topic, and I haven't seen it happening yet, but it would be nice to see it happening someday.
Maybe someday.
These kind of components will also kind of be playing a key role in OPC UA in the future, and especially with regard the information models and how they are really becoming available.
We will see.
Yeah.
We will see. I don't know if we will be doing that, because our customers many times just need some data from the device. They don't care if we are able to implement the correct modeling of the protocol or whatever, just to get the data, to write the data, move data.
Yeah, that's the issue, that the users don't really know to ask for this yet, but I hope that we will see it someday. Okay, thank you very much.
You're welcome. Thank you.